Okay, so the next interesting algorithm that we are going to learn is call it as the merge sort. Now we'll understand why it is called a merge sort, how does it work, and we will discuss all of them in the next few videos. But before we go there, an important question arises is why should we learn another sorting algorithm? Why should we learn? Why should we learn another sorting algorithm? Another sorting algorithm, right? So we have already learned about an insertion sort, right? So given an array, we can sort them using a insertion sort. So the big question here is why should we learn another sorting algorithm if you have already learned an algorithm called an insertion sort? So there are a couple of very interesting reasons. So the first reason here is if you look at an insertion sort algorithm, in the worst case, it will take order of n square time. Of course, it has the best case time complexity as well, right? So the best case time complexity of this algorithm is order of n. So which is very good. But there are still some cases where it require order of n square time. So imagine, right? Now the important question here is there any sorting algorithm that can improve this worst case performance? So imagine I have some sorting algorithm, whatever it may be, whose worst case time complexity is, let's say, order of n log n, let's say, right? So we do not yet know whether such algorithm exists, but suppose it does, right? Let's say the worst case time complexity of that particular sorting algorithm is order of n log n. Wouldn't be that better? That be better? So we already know from our discussion on complexity that an algorithm which takes order of n square time grows much faster than with the order of n log n time. As my value of n increases, n square increases much faster than n log n. So asymptotically, order of n log n is significantly better than order of n square, right? And here for now onwards, whenever I say order of, I mean it's a big O notation unless stated otherwise, right? When I say order of, I mean it's a big O notation. So if there exists an algorithm with a worst case time complexity is order of n log n, it is certainly better than my insertion sort algorithm in the worst case. As the input size increases, the new algorithm will perform better than my insertion sort algorithm. So we will show in this chapter that merge sort has the worst case time complexity is order of n log n. This is one important reason we should learn the another sorting algorithm called a merge sort. The second reason could be by learning the merge sort, we will also learn one of the very powerful concept called a divide and conquer strategy. Divide and conquer strategy. This is extremely important technique for designing an algorithm. There are other strategies are there like greedy, dynamic programming and all. But as we progress through this course, we will learn each of them. But divide and conquer is like a tool or the strategy, right? Or the tool or like a strategy that you have at your disposal right now. We are solving a simple problem. What is the problem we are trying to solve? Sorting is one of the simplest problem we are trying to solve. But in the real world, you will need to solve many complex problems using the data structures and algorithm. One of the most powerful strategy used in designing such algorithms or the efficient algorithm, which is a divide and conquer. So we will introduce this strategy through merge sort algorithm, and later you will see the technique being applied in many other algorithms and the data structures. But first we need to understand the concept, and the merge sort is a great way to learn that. There is another practical reason. So the third practical reason why should we learn the another sorting algorithm called a merge sort is, suppose you have a very large data set. So large data set that doesn't fit into your RAM. Let's say this is my RAM, okay, and this data doesn't fit into your RAM. So imagine you have an array that is 8 GB file. right? So array of size is 8 GB, right? But your system has only 2 GB of RAM. In such cases, the merge sort or the variations of it can be extremely useful. It can work much better than the insertion sort and many other sorting algorithm when dealing with a large amounts of data stored on the disk, right? So we will discuss this in more detail at the end of this chapter. So to summarize this, there are the three main reasons to learn the merge sort or another sorting algorithm. From the computational perspective, merge sort has the better time complexity, better worst case time complexity than the insertion sort algorithm. And also it had introduced the powerful strategy called divide and conquer, which is widely used in algorithm design. And the third one, when dealing with the large amounts of data to be stored on disk, we use a variation of merge sort to handle it, to perform the sorting operation on the large amount of the data. We use a variation of the merge sort algorithm, right? So in the upcoming videos, we will go through each of these reasons step by step and understand them in depth.